Today we're going to talk about similar figures. Similar figures is when you have more than one shape, and the only difference between the two shapes is their size. So if you look at this example, we have two shapes here, same exact shape, but different sizes. So here I have two rectangles, rectangle ABDC and MNOP, and they are similar rectangles. So the symbol we use to show that two figures are similar is this line, which means similar to. So if I were to write this out, I would say rectangle ABDC is similar to rectangle MNOP. Here we have two similar quadrilaterals, and we're going to talk about corresponding angles. So corresponding angles of similar figures are congruent, and we're going to use this symbol to show that angles are congruent. And what I mean by that is that angle A, which is here, and angle M, which is here, they're in the same position in the upper left-hand corner of both figures. So those two angles should be congruent, and we will show that like this. Angle A is congruent to angle M. Another set of congruent angles are D and O, the bottom right-hand corners. So angle D is congruent to angle O. Now if you're writing on the actual figure, the way that we show angles are congruent is by little curved arcs that will cover the angle. So we know that angle A and M are congruent. Similar figures also have corresponding sides. And the corresponding sides, even though they have different lengths, they will increase or decrease all by the same ratio. And we'll talk about that further on the next slide. So first, let's try to identify the similar sides. You can use the corresponding angles to help you. So we know that A and M are corresponding and B and N are corresponding. So that we also know that the distance between the two is our corresponding sides. So here we have line AB is similar to line MN. And another example would be BD. Line BD is similar to line NO. These two triangles are similar, and sometimes when you look at figures quickly, they may not look like they're similar. But just note that even though the right angle is on the left side here and the right side here, they're still similar. This triangle has just been rotated so that it's in a different position. So sometimes I like to redraw the triangle just to make sure, it helps me make sure that I am using the correct angles and letters that are corresponding. So let's look here. We know that angle L is similar, congruent to angle P, and angle K is congruent to angle M, and angle J is congruent to angle N. We can also look at the sides. We know that line JL is similar to NP, JK is similar to NM, and LK is similar to PM, corresponding. So now my two rectangles have measurements for two of the sides. And I want to tell what the relationship is between rectangle ABCD and MNOP. So what I'm going to do is set up a ratio of the corresponding sides. So let's look at this first side, AD. AD is 2, And AD corresponds to MP, which is here, which is 4. So first I can write AD over MP, because those are the two sides that I am comparing. And then I can go ahead and input the values of each line. It's 2 over 4, which reduces to 1/2. So the relationship between those two lines is 1/2. Now I'm going to go ahead and do it for another line segment. How about DC and PO? So I want to see DC over PO, which equals 6 over 12, which also equals 1/2. So since these shapes are similar, the relationship between the corresponding sides is going to be the same. It's the 1/2, and so is this side and this side. They're all going to, if we're going from this one to this one, increase by 1/2, or from here to here, decrease by 1/2. And that's because they're similar. So the amount that they increase or decrease by is the same for each of the sides. So here we have two rectangles, and I want to know if they are similar or not. So first you'll notice that this one over here has been rotated. So I'm going to go ahead and draw it the other way so that I make sure my corresponding sides are correct. So remember in previous slides I talked about setting up ratios. So I see here that this side is 15 and it's congruent, it's corresponding to this side here that's 9. So I'm going to write my ratio 15 over 9. And then this one here is 9 and this one here is 6. So now I'll reduce, this reduces to 5 over 3 and this reduces to 3 over 2. And so the ratios here are not equal to each other. 5 over 3 is not equal to 3 over 2. So these are not similar.